Good day. I'd like to talk to you guys about digital roots and how to check your basic arithmetic for mistakes using the digital root concept and the casting out nines concept. Let's first get into what a digital root is and how to find a digital root. Okay, let's look at this first number here, 5013. So what we do to do a digital root is pretty simple. We're just going to add all these numbers together until there is only one number left. I'll show you what I mean by that. Let's just add these numbers together. So we have 5 plus 0 plus 1 plus 3. Well, we know 5 and 1 is 6. 6 and 3 is 9. So we're going to say the digital root of our number is going to be 9. It's real simple. We just add up all the digits in the number until there's only one number, and that is our digital root. Okay, let's try again with the next number, 7,344. Pretty simple. We're just going to add up the numbers. So 7 plus 3 plus 4 plus 4. Okay, we know 7 and 3 is 10. 10 and 4 is 14. 14 and 4 is 18. So we get 18. But then we're going to keep going until we only have one number left. So then we're going to just keep going. 1 plus 8, that equals 9. So there's your digital root. So in other words, we added up all the numbers. We still didn't get a single digit. So then basically we just keep going. Then we take the digital root of this number. So we just keep going all the way until you have one number left. Okay, let's try the next one here, 1,298. Okay, so we're going to do 1 plus 2 plus 9 plus 8. Okay, so we know 8 and 2 is 10. 9 and 1 is 10. So 10 and 10 gives us 20. Okay, then the digital root, 2 plus 0, that's just 2. So there's your digital root. The digital root of this number, the digital root is 2. It's pretty easy. I'll show you guys another example. Okay, the number 7,777. So that's just going to be a 7 plus 7 plus 7 plus 7. And we know that's the same as 7 times 4. What is 7 times 4? That gives us 28. Okay, and we just need a single digit, so we keep going. 2 plus 8, that equals 10. And then 1 plus 0 equals 1. So there is our digital root, the number 1. So I think you guys can get the basic concept of doing this. You just basically keep moving all the way. You add these numbers together, you get another number. If it's not a single digit, you just keep adding until you get a single digit. That's your digital root. Okay, now casting out nines comes into play with digital roots when we're checking an answer. So I would like to go over the concept of casting out nines as it applies to digital roots. So let's take the digital root of this number here. Simply add them together. Okay, well we know 7 and 2 is 10, or 7 and 2 is 9. And then 9 and 8 gives us 17. 17 and 8 gives us 25, and 25 and 1 gives us 26. So I believe that's correct. If we add these numbers together, let's just do one more time in our head. 7 and 2 is 9. 9 and 8 is 17. 17 and 8 is 25. 17 and 8 is 25. 25 and 1 is 26. So then we're going to keep going. We're going to find the digital root. 2 and 6, we know that is 8. So there's our digital root for this number. The digital root for this number is 8. Now I want to show you guys what casting out nines is. So to do casting out nines, you basically are going to look at the number, say this number here, and you're going to find numbers that add up to 9, and then you could kind of cross them out to get your digital root. You could just kind of cross out numbers that add up to 9 to get your digital root. And I'll show you why this works. So first, let's just kind of do that. So for example, 7 and 2 is 9, so we could cross that out. 8 and 1 is 9, we could cross that out. Look what we're left with. We're left with the number 8. Well, sure enough, that's our digital root. Let's try another problem. Next number down, 1,236. Let's find the digital root, how I showed you from the last lesson. 1 plus 2 plus 3 plus 6. 1 and 2 is 3. 3 and 3 is 6. 6 and 6 is 12. 1 plus 2, that equals 3. So there's our digital root, the number 3. Now, if we do casting out 9's method, go back to our number, we just basically cross out numbers that add up to 9. So we know 3 and 6 is equal to 9. And what are we left with? 1 and 2. Well, sure enough, 1 and 2 is equal to 3. Now, the reason why this works, let's say you have a number 59. Okay, and you want to find the digital root of 59. So you say 5 plus 9, that equals 14, and then 1 plus 4 equals 5. So you can see that if I were to cross out that 9, that the 5 would be the digital root. So no matter what number you have, if you add 9 to it, it's always going to go back to the same number when you're doing this technique. So for example, if I have 169, you see if I add those together, I get 1 plus 6 plus 9. 1 plus 9 is 10. 10 and 6 is 16. And then 1 plus 6 equals 7. So you can see if I were to add 7 plus 9, that equals 16. 1 plus 6 equals 7. It just goes right back to the digital root. So no matter what number you have, if you add 9 to it and you take the digital root, you're always going to go back to those same numbers. So a way to do this is just simply cross out any numbers that add up to 9 to quickly find your digital root. So let's go through a couple of exercises, a couple practice problems to practice this concept and make sure it's ingrained in your mind, because I'm about to show you a really, really nice way of using these two concepts to quickly determine if your answers to your arithmetic are correct. Okay, let's find the digital root by casting out 9s. We'll do the first number you see here. So what we're going to do is just simply go through and look for combinations of numbers that add up to 9. So we know 6 and 3 equals 9. We can cross those out. 1 and 8 is equal to 9. We cross those out. 7 and 2, there's another 9. So what we're left with is just 2. So we could say the digital root equals 2. Okay, the next number down. Cast out 9s, we just... We know 5 and 4 equals to 9, so all we're left with is the 3. Whoop. Sorry about that. All we're left with is the 3. So we could say that the digital root there equals 3. Okay, the next one, we'll cast out a 9 automatically. You see a 9, go ahead and cross it out. 6 and 3 equals to 9, so what we're left with is 1 plus 1 plus 1. That equals 3. So there's your digital root, 3. I hope you guys can understand this concept. It's pretty simple. We're just finding the digital root by casting out 9s. If you guys have trouble, go through, watch it again. It's a pretty simple concept. I'm sure you guys can understand just by going through a couple times. Give us a couple practices. And now I'd like to show you how you could use these concepts to check your answers for mistakes. And you are going to be surprised that they don't teach this in school. This is an absolutely brilliant method, brilliant concept to check your answers. You guys are going to have a lot of fun with this. Okay, let's try this. 125 plus 364. Now let's real quick, let's just add these up. 5 and 4, that makes 9. 2 and 6 is 8. 1 and 3 is 4. Okay, so now we're going to do a little digital root and see if we can't see a pattern here. So what's the digital root for this top number? We're going to say the digital root is 1 plus 2 plus 5. Okay, that equals 8. And the digital root for the bottom one is 3 plus 6 plus 4. Well, we know from our last lesson, casting out nines, we could just cross those out. 3 and 6 adds up to 9. We could just cancel those out. Our digital root is 4. So then we look at the operation. What operation are we doing? Well, we're doing addition. Okay, we're doing addition. So let's add these two numbers together, our digital roots. Let's add our digital roots together and then take the digital root of the answer. Kind of like this. 8 and 4, we know if we add those together, we get 12. Okay, 1 plus 2, that equals 3. So our digital root for the operation is just going to be a 3. Let's see if we can't get that to match up with this. If we take the digital root of the answer. So 4 plus 8 plus 9. Okay, we know cast out nines, you could just cross that out. So all we're left with is 4 plus 8. We know that's 12. 1 plus 2, that equals 3. Well, lo and behold, look at this. These match up. So this is a way of checking your answer to see if you get it right by these digital roots, if they match up. I'm really surprised they don't teach this in school. You could apply it to pretty much everything. Multiplication, subtraction, division. You could apply it to taking the squares of a number if you're taking the squares, squaring numbers. Let's practice a couple more. You guys start to see how this works. Okay, let's look at this problem. 348 minus 127. Okay, let's just do this simple arithmetic. 8 minus 7 is 1. 4 minus 2 is 2. 3 minus 1 is 2. Okay, that's the answer we get. Now let's take the digital root. So 3 and 4. 3 and 4 is 7. 7 and 8 is 15. So if we add those together, 3 plus 4 plus 8 equals 15. 1 plus 5, that equals 6. So there's our digital root. You could do this in your head if you want to. The reason I'm writing these out just to kind of give you guys a visual. So, if you could do this in your head, that's fine. It's perfectly fine to do that. So the next one, we could see 1, 2, and 7, 127. Well, automatically we know 7 and 2 is 9, so we could kind of cross those out. Right? 1 plus 2 plus 7. Cross those out, all we're left with is 1. So then we look at the operation. What are we doing? We're subtracting. So 6 minus 1, because those are the digital roots. Here, I'm going to move this guy over just a little bit like that. So 6 minus 1, that equals 5. So if we did everything right, then the digital root of the answer should also be 5. So let's see. 2 plus 2 plus 1. Sure enough, that equals to 5. So you can see these two answers check out this way. Now, this isn't a 100% way of checking. I'll explain what I mean by that, but it'll give you, a 99.9% chance that you're sure that you got these answers right. Okay, so what do I mean by it doesn't always work? Well, here's an example that I wrote down, and the number is wrong. I wrote the number wrong on purpose. It doesn't equal 591. So the answer is wrong, and it's going to give you a positive result using casting out nines anyway. And I'll show you what I mean. So we know that the top one, 2, 9, and 7, right? That's going to be 2 plus 9 plus 7. That equals 18. 1 plus 8 equals 9. 3, 8, and 4, the digital root of that. 3 and 8 is 11. 11 and 4 is 15. 1 and 5 equals 6. So then we look at our operation. 9 plus 6 equals 15. The digital root for that is 6. And we could see that 5, 9, and 1 is going to give us 15. So the digital root there is 6 also. So you see we're getting a positive result even though that the answer is wrong. So it doesn't always give 100% assurance. So this is basically what you do. That if let's say you get an answer and this number and this number do not match, let's say they do not match, then you know 100% that it's wrong. In other words, this method will give you a positive result for a wrong answer. In other words, it doesn't tell you 100% if you're right. It tells you 100% if you're wrong. So if they don't match, if these two numbers don't match, then it's 100% wrong. Does that make sense? It gives you a positive for a wrong answer. It'll let you know if you got the answer wrong. It won't let you know if you got it right. It's still very helpful, and I'm going to show you guys a couple more examples doing multiplication and such. Okay, let's just do a real simple 12 times 15. Using some techniques that I taught you earlier. Going from base 10, we'll say that this is plus 2, this is plus 5. Okay, left-hand side we get 17, right-hand side we get 10. Carry that equals 180. If you want to know how to do this, look at my video of multiplying numbers near a base. But let's try this out. So the original problem we had is 12 times 15, and I'm saying that equals 180. So let's see, 1 plus 2, that gives us 3. 1 plus 5 gives us 6. Okay, and we know 3 times 6, because remember, whatever operation we're doing, that's what we're going to do with the digital roots. So we're multiplying, so that's the operation we're going to do with the digital roots. Okay, 3 times 6, that equals 18. Keep going, keep taking the digital root. 1 plus 8, that equals 9. So there's our digital root. Well, lo and behold, look here. The answer, 1 plus 8 plus 0, that equals 9. So you see these two numbers are the same. So we don't know if we got it right. We know we didn't get it wrong, if that makes any sense. I know it's kind of a strange way of saying it. Let's try a couple more. So 312 times 24. I kind of went ahead and did the work ahead of time. I got the number 7,488. So let's just take the digital root. 3 plus 1 plus 2. 3 and 1 is 4. 4 and 2 is 6. Okay, the digital root of the bottom one, 2 plus 4, that equals 6. So then we look at the operation, which we say is multiplication. So we're just going to multiply the digital roots and then take the digital root of that answer. So we look at the operation, do that same with the digital roots. So 6 times 6, that gives us 36. 3 plus 6 equals 9. So that's our digital root. We should get that if we take the digital root of the answer. So 7 plus 4 plus 8 plus 8. 7 and 4 is 11. 11 plus 8 is 19. And 19 plus 8 equals 27. Okay, if I add up all those, I get 27. 7 plus 4 plus 8 plus 8 equals 27. So now I want to take the digital root of that. 2 plus 7 equals 9. Sure enough, this number and this number check out. Well, I hope you guys can get something out of this. This is how you do digital roots and casting out nines. It's a pretty cool little concept. You could use it for all sort of operations if you want to do subtraction, multiplication, division. If you want to do stuff with square roots or squaring or cubing. I'm going to make a video on that later on. We'll do the same kind of thing with division, squaring, and cubing. Today I went over addition, subtraction, and multiplication. And I hope you guys can understand this concept. It's pretty easy. I really don't know why they don't teach this in school. It's absolutely brilliant way of checking your answers for mistakes. If you guys like this video, please like and subscribe. Write a comment down below if you have any problems or want to know anything about this video. Just write a little comment down below. I appreciate you guys' time, and thank you for watching.